Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iyman bin Abu Bakar, and today I will be representing the Erosion and Sediment Control Plan Design Department for my parent company, which is Pang and Associates Consultants. Today, I will be doing my major presentation about the Erosion and Sediment Control Plan at Project Site Lot 154347 for SEAA 3022 Integrated Design Project 1. Before we can continue with the Erosion and Sediment Control Plan or ESCP, I would like to do a bit of an introduction for my company, Pang and Associates Consultants. Starting with its background, this company was founded by a group of civil engineering students from University Technology Malaysia, UTM, which specializes in various fields regarding civil engineering. Our vision is to be a successful consulting company which excels in all the fields. Next, our mission is to deliver the highest quality services while excellence in every aspect to meet the client's requirements. We also aim to provide the most effective solutions to our customers in the construction industry by using our field of knowledge and experience. And finally, our motto is striving for the best quality in every aspect. Okay, next, as you can see, this is the organization chart for our company with Pang Jingheng at the helm, which is the project manager, and Iyman Zaidani as his assistant project manager. The company is divided into four major departments, and as you can see, I am partnered with Fatin Shwada in the Erosion and Sediment Control Planning department. Okay, we will now start with the project description. The project site is located at Mukim Tebrau, Johor Bahru at lot 154347. This development aims to develop an industrial area consist of a variety type of clusters for the use of respective parties, and the total project area is at 45.029 hectares. Next is our work schedule. Our work schedule is in the span of 16 weeks. And as you can see, the work program for each department is concurrently moving together. And now, as you can see, on the left side is the satellite view of the project site. And on the right side is the erosion and sediment control plan layout. This is the plan where all the BMPs is located, such as the sediment basin, silt fence, and also the division of catchment area is divided. Okay, for the next slide will be the design guideline for the ESCP. The design guidelines used for this project's erosion and sediment control plan is based on the second edition of the Department of Irrigation and Drainage Malaysia's Urban Stormwater Management Manual or MASMA. Based on the natural functions and the design objective of each facility, these BMPs can be further classified into three types, which is erosion control, runoff management, and sediment control. Next, the runoff management and sediment control BMPs has been appropriately constructed and designed based on the Universal Soil Loss Equation or USLE and the Modified Universal Soil Loss Equation MUSLE. Okay, next is for the design criteria for the BMPs in the worksite. The assessment of the rainfall data is very important because it is to ensure that the temporary drainage can withstand the site's maximum amount of stormwater, and also to ensure that the sediment basin that is designed can withstand the site's sediment discharge throughout the project's multiple phases. Okay, now we will enter the part of the presentation where we estimate the rainfall for the area where the project site is located. In this part of the presentation, we will go through the average recurrence interval or ARI, time of concentration, the average rainfall intensity, and finally the peak discharge estimation. Okay, for the average recurrence interval or ARI is a term that is used where the rainfall or subsequent discharge is estimated based on the selected frequency or return period. ARI is also the average interval between the rainstorm events with a greater intensity than the similar magnitude, volume, or duration. ARI can be expressed in a mathematical equation as TR equals to 1 over P multiplied with 100. TR is the average recurrence interval and P is the annual accidence probability. We will move to the time of concentration, TC. Time of concentration is the time taken for the runoff to flow from the most remote point upstream in the catchment area to the point under consideration downstream. The formula for TC is TC equals to T naught plus TD. T naught consists of another equation and TD also consists of another equation which is 1 over V, as you can see on the left side of the slides. Now we will move to the average rainfall intensity. The intensity, duration, frequency or IDF curves shows that the relationship between the design rainfall data that is required for the use of the peak flow estimation. On the right side of the slide, you can see that the average rainfall intensity can be estimated by using the empirical equation as, as mentioned below. And finally, we will go through the peak discharge estimation or Q peak. The rational method that is used in the current project is the most frequently used method which gives us a satisfactory results of the peak discharge estimation for small catchment areas. Hence, our work site is divided into three smaller catchment areas to calculate the peak flow. The peak discharge can be calculated by using the formula stated below as Q equals to C multiplied by I multiplied by A divided by 360. Okay, in this slide, we can see the sample calculation for the peak discharge estimation. The sample we took is from the calculation of the peak discharge in catchment area 1. Okay, after using the Microsoft Excel for calculation, we tabulate the data into each category. And as you can see in the table, the data for the peak discharge for each catchment area. Okay, now we will move to the design for the temporary drainage. Before any earthwork can be done, a temporary earth drain must be built to direct the runoff surface water. The design that we have chose for the temporary drainage for this work site is in the trapezoidal shape. And for the dimensions, it can be calculated by using the formula below. And as you can see from the drawing on the slide, this is the drainage type 1 that we have designed for the work site. Okay, in the next slide, we can see the sample calculation for the dimensions of the temporary drainage design. The sample calculation is taken from the catchment area 3. And for temporary drainage type 1, after calculating the dimensions for the temporary drainage using Microsoft Excel, we tabulated the info and put it into a table, which you can see in this slide, where all the criteria and dimensions of the drainage can be seen. Okay, next we will move on to the sediment control BMPs or best management practices. Sediment control is a technique or a building used to prevent eroded soil from the construction sites from being swept away and contaminating the surrounding waterways. For the sediment control BMPs, we will go through the calculation for the soil loss estimation, the sediment yield estimation, the design of the sediment basin itself, and other sediment control BMPs. Now we will go through soil loss estimation. Soil loss estimation is important due to the fact that we need to assess the danger of erosion at the site location. The soil loss is measured before the development began, during the earthwork without control, and finally during the earthwork while under control. After the soil loss is measured, the erosion risk can be assessed. The soil loss estimation can be calculated by using an equation known as the Universal Soil Loss Equation or USLE. USLE is used to estimate the soil losses under various agricultural systems and land management techniques. The formula, as you can see in the slide, is A equals to R factor times K factor times LS factor times C factor and finally multiplied by P factor. Okay, now we go through the sample calculation for the soil loss estimation. The sample calculation flow, as you can see, is from the left to the right. This is a continuation from the previous slide, and in this sample calculation, we can obtain the soil loss estimation as you can see in the slide. And now after calculating the necessary data through the Microsoft Excel, we can tabulate the data, and you can see in the slide as the soil properties for the site. Okay, now as you can see, this is the result for the soil loss estimation for each condition, site condition, and for each catchment area. And in this slide, we can see for the condition of the existing work site. For this slide, it shows the soil loss estimation result for the uncontrolled earthwork. And finally, for this slide, it shows the result for the soil loss estimation for the condition, for the site condition of the controlled earthwork. Okay, after estimating the soil loss from the work site, next we will estimate the sediment yield. The sediment yield is the amount of sediment expected at the end of the drainage point from the designated site. To size and maintain sediment control BMPs, this estimation is important and is utilized to forecast how much sediment will be present at the work site. The assessment of the catchment's sediment yield because of a particular storm event often uses the modified universal soil loss equation or MUSLE. This empirical relationship is represented as the equation below. Okay, now for the sample calculation for the sediment yield estimation. As you can see, this is the calculation that we use to estimate the sediment yield of the project site in catchment area 1. In this slide, we can see that for the results of the sediment yield estimation, we start with the runoff volume. We can see for the parameters for each catchment area. Okay, finally, for the result of the sediment yield estimation, the sediment yield estimation data can be is tabulated in the table below, and as you can see, for the parameters, and finally, as you can see at the bottom of the slide, you can see the sediment yield that is in tons for each catchment area. Okay, next we will move to the design for the sediment basin. The sediment basin typically consists of an impounded area, a dam, a riser, pipe, outlet, and or an emergency spillway. The structure is created by excavating or building an embankment across the waterway or other suitable locations to collect and hold sediment from the site's clay or vegetations before the permanent drainage structures are built or the permanent vegetation is established. It has the same function as a sediment trap, but for a larger catchment area. The temporary detention basin is intended to be maintained throughout the construction until the site area is permanently protected against erosion, or a permanent detention basin or a water quality control structure is built. Okay, next we will move to the design criteria for the sediment basin. For the first criteria is the design criteria of sediment traps for sediment control, which is on the top left. And at the bottom of it is the sediment basin types and the design considerations. On the right side of the slide, on the top right slide of the slide, is the design criteria of sediment basin for sediment control. And finally, at the bottom right is the dry sediment basin sizing criteria. Okay, now for the final calculation, which is the sample calculation of the sediment basin design. As you can see, this is the sample calculation, and like before, the flow of calculation is from the left to the right. This is a continuation from the previous slide, and it shows the determination of the Q riser, the sizing of the spillway, and finally for the trapping efficiency. Okay, after calculating for each sediment basin, we can tabulate all the data in the dry sediment basin design. So you can see for the first table is the parameters for each catchment area, and next is for the dimensions for the basins in each catchment area. Okay, for the next tables, we can see for the info for the sediment storage zone has been tabulated according to each catchment area. And finally, for the overall basin design, we can see that each catchment area has its own sediment basin and with each its own dimensions. Okay, next we can see the tabulation of data for the sizing of the basin outlet and also for the total basin depth, including the spillway for each sediment basin in each catchment area. And finally, in this slide, we can see the trapping efficiency for each sediment basin in each catchment area. Okay, now we will move to other sediment best management practices, such as wash bay. From wash bay, we can remove debris from a moving machinery before it exits the project site. And next is silt fence. We can use silt fence to prevent sediments entering a tiny bare areas or location with a modest slope, and usually is utilized during the earthwork phase. And finally, we can use a technique called hydroseeding or turfing. Hydroseeding or turfing is one of the most economical methods in stabilizing and protecting soil surface from rainfall and also runoff of disturbed area. The hydroseeding technique was applied to the slope surface during the slope building in the research location, and also that hydroseeding is to be used to stabilize the slope surface on both cut and also fill slopes. And with that final slide, I would like to say thank you for lending me your time and for listening to my presentation, and Assalamualaikum.